powerful earthquake in the northwestern Caribbean, a magnitude 7.6 off the coast of Honduras. It was actually about 130 miles off to the south-southwest of Grand Cayman.
Beneath the turquoise shimmer of the Caribbean Sea lies a world few imagine, and even fewer have seen. A realm of shifting crust, shadowy crevasses, and ceaseless geological unrest. The islands that adorn this basin, Guadeloupe, Dominica, Martinique, stand as green beacons atop a vast, trembling foundation. But in recent weeks, the pulse of this earth has grown tempestuous. A swarm of earthquakes, one after another, reverberates through the deep, their collective energy rippling outward, and, according to emerging measurements, altering the shape of the seafloor itself. At the center of this unfolding disturbance, teams of scientists scramble to decode alarming signals. Clusters of seismic pops and groans that hint at processes powerful enough to shift the very architecture of the ocean bed. The region, already familiar with tectonic stress, now faces an episode so unusual that global geological networks are abuzz, and local communities are watching, waiting, and bracing for what may follow. How did such a mighty quake swarm begin? And what might it mean for those who live above this ancient, volatile rift? Are these simply routine tectonic grumblings, or is there something new and more profound awakening in the Atlantic depths? Chapter 1. The crack that changed everything. Could a single seismic event reshape the Caribbean floor? That's the question dominating public and scientific discourse after reports surfaced of a powerful earthquake and possible new underwater crack. Recent seismic monitoring has confirmed that a magnitude 7.6 earthquake struck the Caribbean Sea. A shock big enough to generate significant seismic echoes, deform the seafloor, and potentially tear open cracks in the oceanic crust. But what sets this event apart from more common tremors in the area? Most earthquakes along the Caribbean's network of faults leave behind fractures, often minute and scattered. But this quake's extraordinary force appears to have created a gaping, well-defined fissure that is now being mapped by undersea sensors. This is not merely the gentle shifting of ancient faults. It is a dynamic ripping and sudden movement along a tectonic boundary that remains under scrutiny. The scale of this rupture has captured the attention of geologists globally. While earthquakes can relieve built-up pressure, they sometimes trigger sharp, jagged tears and abrupt displacements. Preliminary sonar surveys and seismic readings have imaged a significant new crack, whose length and breadth exceed those typically observed from single shocks. Early evidence suggests the area involved is not just a narrow break, but part of a broader zone of disturbance resulting from immense tectonic stress. It is too soon to tell if the fissure will widen further or slowly settle. In this restless zone, the Atlantic's steady pressure meets the edge of the Caribbean plate, an ancient interface fraught with seismic history. As fresh data pour in, one question persists: what new consequences might this crack unleash? Not only on the sea above, but on the lands and communities perched so precariously inland. Chapter 2. Quake Swarm ignites the basin. What happens when the Earth's heartbeat becomes a frenzy? In the past days and weeks, a burst of earthquake activity has blossomed just east of Guadeloupe, Dominica, and Martinique. Each tremor, while rarely cataclysmic in isolation, reverberates in rapid succession, creating a pulse of motion that spreads across the basin. These are not lone titans, but a collective chorus of quakes, their impacts impossible to ignore. Why do some earthquakes cluster in swarms rather than occur as solitary shocks? The answer, geologists explain, lies in the shifting stresses deep within the Earth's crust. Swarm earthquakes differ from typical aftershock sequences. Instead of following a major quake, they erupt as a series of moderate events, often within days or hours, and sometimes without a clear main shock. This ongoing Caribbean swarm is remarkable both for its persistence and its spatial extent, a sign of widespread tectonic readjustment along and near fault lines. Each event releases pent-up stress, but the frequency, density, and distribution suggest a region on edge, possibly approaching a broader rearrangement of the plate boundaries. Sensors from regional seismic arrays capture these tremors in dramatic detail, mapping a network of movement across hundreds of kilometers. Swarms are notoriously hard to predict, sometimes dissipating without drama, other times acting as preamble to major tectonic events that change landscapes and coastlines. Will this Caribbean swarm be a passing episode, or could it portend a larger upheaval in days or months ahead? Scientists remain on alert, watching for signs, a spike in activity or a quiet fade, knowing that in seismology, patterns often reveal their meaning only in hindsight. Chapter 3. Seafloor rising. New measurements. Can an entire ocean floor rise in the wake of seismic unrest? According to satellite readings and deep ocean instruments, the answer, even if scaled, appears to be yes. New measurements indicate that the series of earthquakes in the Caribbean has led to local, measurable uplifts of the seafloor. What forces can push solid bedrock upward, even by a few centimeters below thousands of meters of water? Earthquake mechanics under the sea can be especially dramatic. The overlying water both masks and amplifies the effects, smoothing the shockwaves but allowing for vertical motion that, on land, might be more restricted. Following the most recent quake swarm, sensors placed on the seabed, corroborated by satellite-based radar and GPS, have measured subtle but significant elevation changes. These uplifts, while generally on the order of centimeters to tens of centimeters, represent vast volumes of rock and sediment being forced upward, a clear sign that underlying faults have slipped or reactivated. Such movement is not unprecedented. Similar uplifts have been documented following major quakes in Japan, Indonesia, and Alaska, sometimes triggering tsunamis or altering currents. For the Caribbean, these elevation changes are still being mapped and studied, but they confirm what many experts suspected. Seismic unrest here is not merely a surface phenomenon, but one that is reconfiguring the region's very foundations. Could these vertical shifts bring new hazards or signify a longer, slower transformation, a tectonic narrative that will unfold over centuries? Experts are now working to unravel exactly how much the floor has moved and how future shaking might reshape the region further. Chapter 4. Fault lines. The Caribbean's hidden borders. What invisible scars crisscross the Caribbean's depths, waiting to be activated by tectonic strain? Beneath sunlit waters, the seafloor is stitched with faults, some mapped, others still only suspected. The recent earthquake swarm has spotlighted these hidden boundaries. At its core, the Caribbean is a tectonic mosaic. The Caribbean plate floats between the formidable North American plate to the north and east, and the South American plate to the south, its movement shaped by ongoing collision and grinding over millions of years. Along these borders, energy accumulates until, suddenly, it is released in seismic outbursts that reshape both sea and land. Geoscientists use the echoes of earthquakes, seismic waves, to probe these faults, building ever more detailed models of where the Earth is strained to breaking. Right now, the area of concern lies east of Guadeloupe and Martinique, along an active boundary famous for prior megaquakes and now scarred by a fresh rupture. Each shock brings new detail. These fault lines, after all, are the underpinning of the islands themselves. The Caribbean's lush arcs were born from ancient volcanism and plate collisions, processes that never fully sleep. Every paradise, it seems, is built on moving ground, and each discovery challenges researchers to ask, how many more hidden fractures and dangers remain beneath the surface? Chapter 5. The mystery of the undersea crack. Can the ocean keep its secrets, even in an age of advanced sensing? The underwater crack revealed in the wake of recent seismic events proves there is still much we do not know about our planet's undersea realms. How could such a sizable fissure appear so abruptly, Earthquakes cause both horizontal and vertical displacements. Sometimes, when tectonic boundaries slip suddenly, cracks and faults widen, slicing through both sediment and bedrock underwater. The particular fissure linked to the recent 7.6 quake stands out for its scale and apparent novelty. Early readings suggest it may be longer and more pronounced than others documented in the region. Imaging with sonar and seismic tools is ongoing, but some scientists propose this crack may act briefly as a pressure release valve, venting stresses that might otherwise accumulate dangerously. At the same time, there is concern. Every large submarine fissure creates unpredictable new pathways for water, heat, and possibly volcanic gases or fluids. For now, the true fate of the crack remains a mystery. Will it heal as sediments settle? Or will it become a new scar on the map of regional hazards? Each investigation returns more questions, reminding us that the ocean's deepest landscapes still hold their own enigmas. Chapter 6: Shockwaves across the archipelago. How far can an earthquake's tremors reach? The recent 7.6 magnitude quake at the edge of the Caribbean plate sent shocks cascading through the archipelago. Not just the epicentral zone, but neighboring islands, St. Lucia, Guadeloupe, Dominica, Martinique, and Antigua, felt the tremors. Sensitive instruments registered ground motion far from the initial shock, confirming how seismic waves can travel through both rock and water, ricocheting off geological boundaries. Local communities, too, felt the power. Houses rattled, and daily life was interrupted as the Earth's energy made itself known. Beyond the immediate shaking, there is the aftershock sequence, smaller but significant tremors that keep people and scientists alike on edge. These aftershocks offer opportunities. With every jolt, seismic networks gain insight into the movement of faults and the buildup or release of stress. These learning moments are part of why scientists refer to major quakes as both testing grounds and reminders of nature's complexity. Will the Caribbean islands settle back into calm, or has a new era of tectonic instability begun? The events of recent weeks have shown that in this region, the Earth's drama rarely confines itself to a single act. Chapter 7: The Puzzle of Seismic Swarms. Why do earthquakes at times cluster in swarms rather than as lone events? The current cluster east of the Lesser Antilles presents a classic puzzle. Each quake is individual, yet all seem part of a connected wider disturbance. Seismic swarms, scientists explain, are often driven by two mechanisms: shifting fluids, be it water, magma, or gases, or sudden redistribution of stress along linked faults. In the Caribbean, the pattern of tremors, spread tightly across a broad front, may indicate the region's network of faults is responding en masse to a major tectonic push. Unlike standard aftershock sequences following a large quake, swarms can occur without a single initiating event. Their duration and intensity are unpredictable. Sometimes they build toward a larger rupture. Sometimes they fade to silence. Right now, the swarm's spread and persistence have led some experts to suspect deeper processes are at work, possibly related to long-term strain between the Atlantic and Caribbean plates. As seismologists track every event, the key question is whether this swarm represents a foreshock period before something bigger, or whether the region is simply realigning after the latest major quake. Chapter 8: Plate Boundaries, the Atlantic versus the Caribbean. What forces drive the endless movement beneath the Caribbean? At the heart is the interaction of two oceanic plates, the Atlantic ever pressing westward, and the Caribbean jostling in response. The boundary, particularly along the northern arc, remains a site of dramatic and sometimes dangerous friction. Oceanic plates are immense masses of rock, moving slowly but inexorably. The Caribbean's northern boundary in particular is a tangle of transform faults and subduction zones. Here, sudden slips can send shocks not just through the rock, but through society. The ongoing earthquake swarm and the new crack in the ocean floor both suggest that this dynamic interface is experiencing an episode of heightened stress. Whether this surge is part of a long-term pattern or an isolated drama, no one can yet say. But history tells us that the tensions here, while sometimes absorbed without incident, have the capacity to trigger catastrophic events. The interplay between the plates ensures the region will never be truly still. Scientists can and do map the boundaries with increasing detail, but every rupture reminds us that our knowledge is always provisional. Nature, in the end, writes the final script. Chapter 9. Discovery. Unseen life at the depths. While the Caribbean's earthquakes draw the world's attention, the deep ocean remains mysterious in other ways too. Recent research in the Pacific Ocean, for example, revealed evidence for over 30 potentially new species discovered in deep-sea surveys. While these discoveries are not directly from the Caribbean, they underline how much of the underwater world remains unexplored and what may be revealed through both catastrophe and curiosity. Major tectonic events, like quakes that crack open the seafloor, create new habitats, fresh vents, mineral-laden seeps, and chemical-rich environments that can foster unique forms of life. In the Caribbean, as elsewhere, new fissures and shifting sediments could, in theory, create microhabitats ripe for biological exploration. Each scientific mission into these depths holds the promise of finding the unexpected, whether it's strange new life or previously hidden geological features. Such discoveries are a reminder. While seismic violence disrupts, it can also create, opening new realms for scientific investigation and perhaps for life itself. Chapter 10. Tsunamis. The powerful aftermath. When the ocean floor moves, the overlying water shifts as well, and sometimes dramatically so. Tsunamis are among the most destructive natural hazards triggered by undersea quakes, with energy rippling outward in waves that can cross entire basins. Could the recent Caribbean events have triggered tsunamis? So far, no destructive tsunamis have been recorded during the present period, but the risk remains ever present. In regions where the seafloor is rapidly lifted or dropped, the sudden displacement of water can set off waves that, while rare, have the power to devastate nearby coasts. To manage this threat, the Caribbean is monitored by an array of buoys and satellites. These systems feed data in real time to emergency planners, allowing for early warning in the event of a significant uplift or seismic shock. The density of monitoring is far greater than ever before, but history shows that tsunamis are best respected as unpredictable phenomena. Every episode of uplift or seabed cracking is analyzed with this risk in mind. For now, precaution and technological vigilance are serving as crucial defenses. Chapter 11. Volcanic activity, a rising peril? The Caribbean's turbulent geology is not limited to earthquakes. Its islands are dotted with volcanoes, some ancient, some still active, including those in Guadeloupe, Martinique, Montserrat, and St. Vincent. The link between earthquakes and volcanic eruptions is complex. Tectonic stresses can jostle magma chambers, occasionally triggering eruptions, especially in geologically active arcs. Currently, there's been no confirmed spike in volcanic activity tied to the latest Caribbean earthquakes. However, scientists continue to monitor gas emissions, changes in ground temperature, and signs of unrest at known volcanic centers. Historical episodes have shown that strong earthquakes can precede or accompany volcanic unrest, making continued vigilance essential. In tectonically active settings like the Caribbean, the interplay between quake and volcano is both a threat and a field of ongoing discovery. Chapter 12. The human equation, living with unrest. How do people adapt to an Earth in constant motion? Throughout the Caribbean, the population lives with the reality of seismic and volcanic risk. Communities have developed a culture of readiness, drills in schools, public awareness campaigns, and regular updates from emergency agencies. This preparation, born of necessity and experience, is both practical and psychological. Islanders know that the Earth's movements cannot always be predicted. They balance vigilance with resilience, taking comfort in the strength of community and in hard-earned traditions of adaptation. After each major event, plans and responses are reviewed, refined, and, when necessary, revised. It is a hard-earned wisdom. There is no guarantee of safety, but preparedness is the best defense. Education and systems for early warning play a key role, underscoring that while nature may not warn before it acts, society can be ready to respond. Chapter 13. Lessons from Past Megaquakes. History has not spared the Caribbean its share of major earthquakes. Over centuries, records, both scientific and anecdotal, describe shocks that toppled cities, generated tsunamis, and left lasting marks upon coastlines and islands. In some cases, great quakes have sunk land or lifted new cliffs. In others, volcanic eruption followed close behind. Modern science now allows us to piece together these buried stories. Paleoseismology, sediment records, and the cavioli of ancient coral all hold clues. By studying these archives, scientists and communities gain perspective, reminding themselves that today's unrest is part of a much longer cycle, and that both disaster and recovery have always shaped life in the region. Each past event has led to adaptation, higher building standards, relocation of settlements, and persistent cultural memory. The lessons of the past offer both caution and hope for the future. Chapter 14. The science of detection, satellites and sensors. How do we map what lies hidden beneath miles of ocean? Advances in submarine seismology and satellite technology now allow scientists to monitor the seafloor in unprecedented detail. Arrays of ocean bottom seismometers, satellite radar, and GPS all combine to provide real-time views of tectonic activity. It is these technologies that first flagged the recent quake swarm, mapped the growing crack, and measured the rising seafloor. Every detail is logged and cataloged by research teams, feeding global databases that help track patterns, issue alerts, and provide context for emerging threats. Despite these leaps, limits remain. The ocean's vastness and complexity mean that some mysteries endure. Each answer, it seems, only opens new questions about how the Caribbean and the wider world responds to the endless shifting of the plates. Chapter 15. Unwritten chapters beneath the deep. If the Caribbean's bedrock could speak, what stories would it tell? Every quake, every crack, every silent, unseen rise of rock beneath the waves is part of an epic that stretches back millions of years. Today, all signs point to a region in flux. Megaquakes split the floor, new cracks form, and swarms of tremors keep people and scientists alike alert. The islands, as always, stand as both sentinels and sanctuaries, shaped by Earth's tempests, yet resilient in their rootedness. Those who live here know, as only those living on the edge of change can know, that the island's silence is never final, and that each day brings the possibility of new stories rising from beneath the sea. It is this watchfulness, this commitment to readiness and stewardship, that defines the true spirit of the Caribbean, a landscape and a people, unbroken by uncertainty. As scientific instruments continue their tireless, silent vigilance in the depths, and as satellites wheel overhead capturing the latest flicker of motion, the future of these islands, like the story of the planet itself, remains unwritten. The world waits, studies, and prepares, knowing that in the Caribbean as everywhere, the profound mystery of nature is both a challenge and the wellspring of all hope. What will the next page reveal? Only time, motion, and our shared vigilance will decide. Until then, the islands endure, the ocean murmurs, and beneath every calm surface lies the living pulse of a restless world.